Okay, good morning. Welcome. Thanks for joining. How was replay last night? Good? All right, we won't speak about it. My name is Edward Name, and I'm the general manager of FSX. With me today is Prashant Bungale, who's a senior product manager on FSX, and Daryl Osborne, who is a senior solutions architect for our file services. And we're really excited to be here today leading this deep dive on FSX for Windows File Server. We launched the service a year ago at last reInvent, and since then we've been super busy as a team delivering a lot of capabilities and new features. So we'll get into some details on some of those as well as talk about the service as a whole today. And we'll also talk about some things that are coming up. So let's look at the agenda specifically. So in terms of how we'll structure this talk, I'll start with an overview of FSX for Windows File Server, its key capabilities, and how it can be used. We'll then dive deep on a number of topics, including availability and durability, performance, total cost of ownership, and admin capabilities. And then Daryl will do some pretty interesting, some pretty fun demos to give you a feel for what it's like to use the product and what it's like to use some of the features specifically. And then we'll wrap up with some Q&A. Okay, and what I'd like to do is to begin with an overview of what FSX for Windows File Server is. So what is it? Well, FSX for Windows File Server is a fully managed native Windows file system that's deeply integrated with AWS. And let's start with what fully managed means. So probably something that almost everyone in this room can relate to is that managing file servers is a lot of work. Before the cloud, you had to manage hardware. So you needed to plan capacity, procure and purchase the hardware itself, set up the storage servers and the volumes, detect and address hardware failures, invest in CapEx to purchase the hardware. Well, now we have the cloud. So that helps. So the managed hardware piece is gone. But if managing file servers on AWS on your own, you don't need to worry about the hardware piece, but you still need to manage the software itself. So you need to install and configure server software, set up and configure file systems, apply Windows updates, manage software licenses, manage backups, monitor security. So still a lot of heavy lifting. So how easy does FSX, which is a fully managed service, make it to create and run file servers? Well, creating a file system takes under 60 seconds in the console. And what we show up here is a screenshot of the console that shows the information that you need to provide when you're creating a file system. There's not that much info. You select between a native multi-AZ and a single AZ deployment. So radio button, which one do you want? You specify the storage capacity. We provide a recommendation on throughput capacity, which is good for almost all workloads. And that's basically all you need to provide for basic info about the file server. And then you need to provide some details on your Active Directory. And that's it. Then you click Create, and you're up and running. And after creating the file system, we make it super easy for you at any time to configure it based on your needs. So through the AWS Management Console and the AWS CLI, we give you a lot of the things that you would expect from a fully managed service, so CloudWatch metrics and CloudWatch alarms. You can take on-demand backups, you can create backup schedules, and you can also apply tags to your resources. And we also have a CLI that we've created for FSX that allows you to configure additional details about your file system via PowerShell. And so you can, for example, set schedules for shadow copies. You can configure information about data deduplication. You can set up quotas. You can choose whether you want to enforce encryption in transit. So there's a bunch of these kind of features and configurations that you can set up through our CLI. And we'll get into details about that, and Daryl will actually show some of that as well. And we've designed FSX for Windows File Server to be broadly accessible. In terms of operating systems, it's accessible from Windows Server 2008 and onward, and Windows 7 and onward. Accessible from Linux via the SMB client on Linux, and also from Mac OS, again, using the SMB client. In terms of compute instances, so of course it's accessible from EC2. It's also integrated with workspaces, with VMware Cloud on AWS, with Amazon AppStream, and you can also access it from on-premises compute instances as well. And for network connectivity, to make all of this possible, we are natively within we support VPN, we support AWS Direct Connect, so if you're connecting from on-premises, we support VPC peering, AWS Transit Gateway, and of course, NVPC access. So a lot of different ways for you to be able to access your file systems across accounts, across VPCs, from on-prem, within a single VPC. Makes it really easy to have this file server be a central place for your data that's accessible from a lot of your end users and your applications. And we know that customers depend a lot on features and capabilities from their file server. And for that reason, a core goal of FSx for Windows File Server is providing a complete set of enterprise-grade functionality. And we really see that as table stakes. So this slide provides some examples of some of the capabilities that we provide. And hopefully a lot of those resonate with you as ones that are important for you for fully managed file servers. And a big request of customers from the start with FSx has been for us to integrate with a rich set of other AWS services so that these file servers are managed and accessed in AWS native ways and that they can be used by end users in ways that they're used to. So we talked about VPC. Of course, we integrate with AWS IAM, KMS, CloudWatch, CloudTrail, CloudFormation, Direct Connect, and VPN. And I talked about a number of the other services on the bottom as well that you can access your file systems from. And I always get most excited about customer slides because it's super rewarding personally to hear how customers are using our services and how these services are helping them solve real-world problems. So, for example, Infor said with Amazon FSx, we have a managed solution that eliminates the need for us to manage the tasks associated with operating file storage, including performing backups and applying software patches. And I won't go through all of the text on this slide, and on our website we have some more quotes and use cases, but really exciting to hear it from customers' words that they really see the value in the fully managed piece. And simplicity and full management are important, as are the feature set and the kind of enterprise capabilities we talked about, but they're not the only thing that you think about. And price and performance are also critical for people making decisions about using file storage and what file storage to choose from. So let me talk about price and performance just a little bit. So today, FSx for Windows File Server offers high-performance SSD storage. And we announced 2 weeks ago that we now offer native multi-AZ storage, so you can choose between single AZ deployments and multi-AZ deployments. And for single AZ, all SSD, it's 13 cents per gigabyte per month. And for multi-AZ, it's 23 cents per gigabyte per month. And we're really excited this week that we announced that coming soon, we will have a second option, which is HDD-based storage. And the HDD-based storage, the pricing for single AZ is 1.3 cents, and for multi-AZ is 2.5 cents. And that's coming soon. Now, if you couple those prices with another feature that we launched about 2 weeks ago, which is data deduplication, your effective cost is actually lower. And data deduplication for the typical file system reduces the amount of storage that you consume by 50 to 60%. So that's what most of you will see for most applications. And so what does that mean in terms of effective price point? So for all flash, all SSD-based storage, 6.5 cents for single AZ, 11.5 cents for multi-AZ. And for HDD storage, less than a penny, 0.65 cents and 1.25 cents for multi-AZ. And in order to serve a broad range of workloads and a lot of performance-demanding workloads, we've designed FSx from the ground up with performance in mind. And it's one of the most critical areas that we've focused on when building the product is the performance. So with each file system, you get less than 1 millisecond latencies, so sub-millisecond latencies. In many cases, you'll see 200, 300 microsecond latencies for most operations. With each file system, you get multiple gigabytes per second of throughput and hundreds of thousands of IOPS. So this performance profile allows the service to be used in again, a really broad array of workloads. And we have designed it for a broad set of workloads. So if you think about traditional network-attached storage lift and shift, so home directories, line of business applications, web serving and content management, software development environments, backup and disaster recovery. And also, due to an announcement 2 weeks ago as well, we now also support high availability SQL Server databases. And Prash will get into some details on that as well. But it's not just kind of traditional NAS lift and shift, also cloud native workloads. We're seeing a lot of those on the service. So media workflows like video transcoding, analytics, HPC, dev and test environments, SaaS applications. And today we're available in 11 regions, and there will be more coming soon. We'll be available in all AWS regions soon. And in the year since we launched FSx, the engineering team has been really busy. And there's a lot coming in 2020 as well, but we launched a lot over the past year. And I'm going to talk about a couple of those launches. So earlier in the year, we launched support for Direct Connect and VPN access. So that allows you to mount or map a file system from on-premises applications or on-premises devices to your on-cloud FSx file system. And we also announced inter-VPC and cross-account and cross-region access. We launched support for shared AWS managed AD. And then a really big request we had from customers was when we first launched the service, we integrated with AWS managed AD, which is fully managed Active Directory. But a lot of customers wanted to use their existing on-premises Active Directories. So we launched support for being able to join your file systems to existing on-premises Active Directories. About mid-year, we launched support for shadow copies. You can think of that as file-level restore by end users. And we also provided the capability for administrators to be able to unlock files from an active user. So for example, if a user goes off on vacation and has a file locked and you need to unlock it as a storage admin, you have the capability to do that. And 2 weeks ago, we launched 7 new features. The first is multi-AZ deployments. So at the click of a button, you can specify you want multi-AZ. High availability SQL Server deployments, user quotas, the ability to manage shares programmatically. So previously, you could manage shares, create shares, and manage them using a Windows native GUI. You can now do that via PowerShell commands as well. We announced support for data deduplication. We lowered the minimum file system size from 300 gigabytes to 32 gigabytes. And we also provide the capability for you to make sure that any client that's connecting to the file system is doing so over a encrypted in-transit connection. And then earlier this week, Andy in his keynote announced the availability of what we're calling local zones. And the first one is in the LA area. And FSx is available on local zones as of a few days ago. And as I mentioned, the HDD storage option is coming soon. And this slide gives you a glimpse of some of the customers using Amazon FSx and some of our partners who are working with customers and helping them deploy it in their environments. And so with that interview, let's dive deep on some topics. 6 areas we're going to dive deep on today are availability and durability, performance and scale, cost effectiveness, security and data protection, admin tools, and migration. And with that, I'm going to hand it over to Prash, who's going to lead us through those.
Thanks, Ed. So let's dive right in, having been introduced to the service now. Let's look at availability and durability first, about how FSx provides you fully managed capabilities around availability and durability. So at launch, we offered a single AZ deployment option, as Ed mentioned. We are now excited to have launched a multi-AZ deployment recently, about 2 weeks ago. With both of these deployment options, the service continually monitors and addresses hardware failures, and it also replicates data within an availability zone. So if a file server or a storage volume component fails, we continually monitor for these failures, and we replace those components in order to ensure continued availability. We also replicate the data so that you get high durability. Now, this is true across both of these deployment options, but with multi-AZ deployment option, we also replicate the data additionally across availability zones, and we stand up 2 sets of deployments, one called the preferred and one called the standby. And we automatically failover whenever there's a failure in the preferred setup so that you get continued high availability for your applications and end users. We automatically take care of the failover and the failback, and the experience itself is actually transparent to your applications and end users. They still continue to use one common endpoint. So let's look at the architecture in a little more detail to understand how this model works. So we have here the AWS cloud, and we illustrate a VPC with 2 availability zones. Let's say you have a set of client instances across these 2 availability zones. You also have FSx on the bottom here, where we show a Windows file server component, as well as storage volume components with replication, as you see in this box. Now, the purple icon in the middle is basically referring to the network interface that FSx provides. The way you use FSx is when you stand up a file system, when you create a file system, you basically specify the availability zone and the subnet in which you want to create the endpoint for your file system. And that purple icon that we show here is really representing that endpoint. It's basically a network interface into your file system. So the clients here are accessing that network interface, that endpoint for the file system. And as I mentioned, we ensure high availability. So just to illustrate that, if the Windows file server fails for whatever reason, we detect that failure and we replace that file server so that you get continued high availability for your clients and applications and end users. We also take care of replication and failure detection and recovery on the storage side. So in this case, suppose a storage volume fails, we immediately recover it, and we recover the replication to make sure that you get continued both high availability as well as durability. We also support access from your on-premises network using Direct Connect or VPN, as Ed mentioned earlier. So let's look at how multi-AZ works in terms of this availability and durability model. In the case of multi-AZ, when you create the file system, you get to pick a preferred and a standby AZ, and you get to basically pick 2 subnets that correspond to the preferred and standby setups. So in this case, there are 2 purple network interface icons that you can see. Those are the 2 endpoints that are presented in the 2 AZs selected. The left-hand one is the preferred, and the right-hand one is the standby. So in this case, as you can see, all of the clients accessing the file system are actually pointing towards the preferred, because that's the AZ and the subnet in which we ensure high availability during most periods of time. And only in the case of failover and failback, for short periods of time, the access will be via the standby setup. So in this case, suppose the file server fails on the preferred AZ. You can see that we replace it, but in the meantime, if I can go back here. So in the meantime, the clients are actually accessing the standby network interface. And then once we replace it, we actually take care of failback automatically so that the clients now access the preferred availability zone. The same thing happens when there are storage volume failures. We take care of those failure detection and recovery aspects all automatically. So all of this, by the way, is happening behind the scenes transparently from your applications and users. That's really the key point here, where you are presented with one common DNS name that refers to the file system. You are mapping the network drive to that DNS name and share name, and everything else in terms of failure detection, failover, failback is all taken care of automatically on the service side in a fully managed way. So in terms of the events that actually trigger a failover in the case of the multi-AZ deployment, it's basically a couple of different things. If the preferred file server's availability zone itself becomes unavailable, or if the preferred file server itself fails, we detect that loss of availability and we immediately fail over to the standby. And then we ensure failback, as I showed earlier. We also perform planned maintenance activities in order to keep your Windows Server software up to date on the file server. And when we do these planned maintenance activities, we actually also perform the automatic failover and failback so that you get continued high availability even when we are performing maintenance activities on your file servers. The next aspect of high availability I'll focus on is support for highly available SQL Server deployments. So you can run SQL Server clusters in two different ways, broadly speaking. You can run them as SQL Server availability groups or SQL Server failover cluster instances, or FCIs for short here. We basically already supported SQL Server availability group deployments on EC2 with a wide set of options, as well as on RDS, for example, with the fully managed SQL Server deployment. But then if you wanted to run a SQL Server failover cluster instance deployment, or FCI deployment, you needed shared storage. And really, to run this deployment with shared storage, you had to go ahead and deploy and set up and configure and optimize and maintain this shared storage solution. And that often involved even using third-party solutions and paying license fees for those third-party solutions and so on. So with our recent launched support for SQL Server HA deployments, you don't need to do any of that now. You can basically stand up an FSx multi-AZ file system. You can set up what is called a continuously available file share. Within SMB, within the Windows SMB protocol, there's a specific feature called SMB transparent failover, which you get when you configure your file share as what is called CA, or continuously available. So all you need to do is stand up a file system, configure your file share as CA, and store your databases and logs for your SQL Server deployment on that FSx file system. Everything else in terms of replication across availability zones, failover, failback, providing the really high continued availability, the non-disruptive continued availability for SQL Server using the transparent failover mechanism is all taken care of in a fully managed way by FSx. Using this, by the way, not only do you get a fully managed solution and you don't have to worry about the deploying, managing, and paying license fees for the custom replication software solutions, but you also get the advantage, by the way, of license flexibility. With availability group deployments on SQL Server, you often have to use the enterprise edition if you have lots of databases, because with the standard edition, you only get to run one database per instance. But then if you're running FCI deployments, like this one that's shown here as an example, you actually get to run multiple databases on a standard edition. So you now get license flexibility in terms of not needing to use enterprise if you don't need it for other reasons. Let's look at one more aspect of durability. We also provide the ability to take a backup of your file system at any point in time. I'll go into a few more details about what these backups mean and what kind of consistency they provide and so on in the later sections. But for here, I'll basically mention that we provide the support for daily automatic backups, where you as the administrator get to define what the schedule is and what the retention period is for these automatic daily backups. And then we store these backups in S3, so you get the high durability of storing your backups in S3. And then we also allow you to take backups on an as-needed basis using either our command line interface or using our console. You can basically take a point-in-time snapshot backup of your file system. Using that admin-initiated backup functionality, by the way, we also support the ability for creating a custom backup schedule. So when I showed you in the previous slide that we provide daily automatic backups, you can basically specify the retention period to up to 35 days. But then if you have compliance requirements to store your backups for a longer period of time or to take backups at a different frequency instead of automatic daily backups, we also support that by way of doing a custom backup schedule. So on our user guide, we provide a very simple tool for you to use using CloudFormation. It actually sets up a pretty nifty solution using CloudWatch events, using Lambda, and using simple notification service, as well as using the API calls into our service, into FSx for Windows itself. It does all of this on the back end. All you need to do is this interface that I show you here as an example. You only specify what file system do you want to back up, what schedule do you want to apply the backups at. So in this case, we are specifying a cron schedule of once every 6 hours, as an example. And then you specify how long do you want to retain these backups. And that's it. You specify these 3 inputs, and the solution, the automated solution takes care of the rest for you. And then you get notified upon successful backups. You get the retention policy applied, all of that automatically. So having talked about availability and durability, let's move to performance and scale now. So as Ed mentioned already, we provide performance that basically comes down to sub-millisecond per operation latencies with our high-performance SSD storage. And as we mentioned already, it's basically hundreds of microseconds for most operations, even the low hundreds of microseconds for most operations. And then in terms of throughput and IOPS, we support really high levels of throughput. It's up to 3 gigabytes per second of throughput and hundreds of thousands of IOPS on a per file system basis. We also support the use of DFS namespaces to scale out your performance across multiple file systems, as I'll talk about in a few slides. And then this number that I talked about, the up to 3 gigabytes per second and up to hundreds of thousands of IOPS, applies when your application is performing what is called direct I/O, meaning that it needs to go to the file server directly and perform the read or the write operation. But a lot of applications are actually capable of taking advantage of client-side caching. In fact, by default, most Windows applications are capable of taking advantage of that. And with that, basically, the first access goes over the network, but all further accesses can be served off of the client-side cache. And here, Windows and SMB provide a rich set of functionality, whether it's things like simple client-side read cache, or it's things like the use of opportunistic locks to also provide write buffering on the client side, or it's things like providing SMB directory leases and so on. So there's a rich set of functionality that allows you to perform a lot of operations in an optimized way locally, which we fully support. So with that, you can perform up to 10 plus gigabytes per second of throughput and millions of IOPS, even on a per file system basis. And then one other thing I'll touch on here is because we support SMB natively and because we have full support for the rich set of features of SMB, with SMB multi-channel, we actually support the ability for a single client to drive up to the full throughput and IOPS capability of your file system. You don't even have to parallelize across lots of clients in order to take advantage of that full performance capability. So that's a really powerful piece of functionality that we support. In terms of how the throughput model works, when you create a file system, as Ed showed you in the initial slide, there's basically storage capacity and throughput capacity that you specify for your file system. The throughput capacity basically determines what's the speed at which the file server behind your file system can serve data to your clients and applications. The higher the levels of throughput, the higher also are the levels of IOPS and the memory that's available for in-memory caching on the server side. So in addition to the client-side caching that I talked about in the previous slide, we also support server-side caching. So we provide you the ability to choose anywhere between 8 megabytes per second and 2 gigabytes per second for your throughput capacity. And these numbers correspond to the sustained or the 24/7 throughput that you'll get for your file system. In addition to this baseline throughput, we also support burst throughput in order to support the spiky nature of most file workloads, where you have the need to drive higher performance, but for short periods of time. So with that, even with the lowest level of throughput capacity, you get almost 200 megabytes per second of burst throughput capability for up to 30 minutes a day. And then beyond this baseline and burst throughput, going all the way back to the storage, you also get higher throughput with in-memory caching on the file server, and there you get anywhere between 600 megabytes per second and 3 gigabytes per second. So I threw a lot of numbers at you in terms of throughput capacity options. You may be wondering, how do I pick the right level of throughput for my file system? It's actually really easy. So with our experience across thousands of customers and with our long experience running file services on AWS, we basically pick the throughput capacity for you. So when you're creating a file system, as soon as you specify the storage capacity, we automatically pick what is called the recommended throughput capacity, as shown in this screenshot. And then if you're not having any specific application needs that you are concerned about, we recommend that you go with this recommended level for most workloads. And then in only the few cases where you have specific needs for your applications that may be higher than this default or maybe sometimes even lower than this default, we recommend that you test your workload with FSX. You look at CloudWatch metrics that we provide for your file system in terms of how much throughput you're driving and how much you're able to drive and so on. And then if the total throughput is approaching the throughput capacity limit, then we recommend that you pick a higher level. So it's as simple as that. In terms of the CloudWatch metrics themselves, we actually emit CloudWatch metrics every minute. We emit metrics like free storage capacity on your file system, the amount of throughput that you're driving both on the read and the write sides, as well as the amount of file system operations, or IOPS, that you're driving for read, write, and metadata operations. We also allow the support of metric math with CloudWatch metrics to basically allow you to do near real-time monitoring of your file system with the sort of resultant metrics that you care about. The last piece I'll touch on in terms of performance is being able to scale out your performance across multiple file systems. So with the Microsoft technology called DFS namespaces, you can set up a couple of namespace servers, and then you can configure your own namespace for your organization. So in this example, I'm showing you a home directory solution where you have the employees whose last names start with A through F in one folder, G through M in another folder, and so on. So in this case, you can actually divvy up your data such that you can actually have each of these namespace folders point to separate Amazon FSx file systems, so that overall, when your client instances are accessing your data, they still get one unified common namespace that they are accessing. They don't need to know where the data is being backed. All they need to know is, I'm accessing the folder A through F, for example. And then behind the scenes, DFS namespaces maps that access over to the appropriate FSx file system that is specified as the link target for that DFS namespace. So with this kind of scaling out, you can actually get 3x the read and write performance in this example using 3 FSx file systems. Let's move to cost effectiveness next. So to start with, with the new HDD storage option that we will be launching soon, we support the ability to choose the ideal storage type for your workload. So if your workload needs the SSD levels of performance for the entirety of the data set, you should be using SSD storage. If it doesn't need the SSD levels of performance for the entirety of the data set, you should be choosing HDD storage as the option. And we'll release more regarding the performance details and performance options for HDD itself as we launch the product. The second aspect of cost effectiveness I'll touch on is data deduplication. So large data sets tend to have a lot of duplication in them. This can increase your storage utilization and your storage costs. Examples of this include user shares that can have lots of users having many copies or even versions of a file, or even subsets of a file that have duplication in them. You can have software development shares where you have most portions of binaries remaining unchanged from build to build across versions. You can use data deduplication to reduce costs associated with all of this duplicated data. The guidance provided here as an example is for typical user document shares, for typical software development shares, and for general file shares that have a mix of these. So you can see that with general file shares, it tends to be about 50 to 60% typically in terms of storage space savings. A couple of things I'll focus on within data deduplication are basically that it works at the sub-file level. So remember, the entirety of the file need not be duplicated, even if there are portions, and these portions need not even be aligned to blocks or whatever. There can be anywhere along the file. The data deduplication will still find those to be duplicates and will save space for you. It uses post-processing optimizations so that it minimizes the performance impact. And then it removes all the duplicated content, and it also, by the way, compresses the common content. So you get the additional benefits of compression along with data deduplication. You can use the remote management PowerShell command line interface that we provide for your file system. You can do things like enabling and disabling data deduplication, customizing a schedule for your data deduplication jobs if you want to do so. When you enable it, it already comes with a default schedule. You don't need to do anything else. And then you can also monitor, as I show in this example, how much savings you're able to get with data deduplication. So in this example, you'll see that I'm able to get about 55% as my savings rate. Another aspect of cost effectiveness I'll touch on is user storage quotas. So administrators would want to often monitor and control individual user-level storage space consumption on their file systems. And with this feature, you can basically do things like configuring quota levels for an individual user or group. You can also choose between track and enforce mode. Basically, with track mode, you get to see which user is using how much storage space and where they are relative to their configured quota limits. You can also choose, by the way, to enforce the quota, where the users that are violating their quota, that are trying to use more storage space than their quota, will actually be denied further storage space consumption. And then you can also do things like get a report of all the current quota violations across all of your users and groups. In terms of the pricing model for FSx, you pay for your file systems and backups separately. For your file systems, you pay for two dimensions, for storage and throughput. So let's walk through an example of how the TCO looks for using FSx. So let's say in your workload, you have 10 terabytes of storage. And with deduplication, let's say effectively you have about 5 terabytes of storage space needed, even though you have 10 terabytes of storage needs. And then in terms of deployment type and storage type, let's say your workload fits well with multi-AZ and HDD in terms of the needs of the application. And then in terms of throughput requirements, let's say the workload needs about 16 megabytes per second on a sustained basis, 100 megabytes per second on a burst basis. And in terms of backup, let's say you have about 1x of the storage capacity needed for backup as well. So with these needs, basically on the file system component, you pay for storage and you pay for throughput capacity. So in this case, the total for the file system comes up to about $200 a month, or in other words, 2 cents per gigabyte month of the original storage that you required. And then on the backup component, it comes up to another $256 for a grand total of $456 per month, or in other words, including the backups, it's about 4 cents per gigabyte month. So this is just an example of how the TCO works with FSx. Let's look at a couple of aspects of security and data protection. All data is encrypted at rest with Amazon FSx. You get to choose the key with which the encryption is performed. We support integration with AWS KMS, or Key Management Service. And we also support the use of customer-managed CMKs in addition to service-owned keys. We also support the option to enforce encryption in transit. So data is always encrypted in transit when you're accessing from clients that are capable of SMB 3.0. But then if you're accessing the file system from older client versions, by default, we allow the connections to be approved, but then without encryption in transit. But you now have the option to enforce encryption in transit, meaning that older clients will not be able to access your file system. We allow you to integrate your file system with your own organization's Active Directory, and we support fully the use of Windows NTFS access control lists, or ACLs. We support network-level traffic access control using Amazon VPC security groups and network ACLs. We also support administrative API access control using Identity and Access Management, or IAM. So you can do things like certain IAM users are allowed to create file systems, delete file systems, certain others are not. And then we allow you to monitor and log API calls using CloudTrail. And we have a whole range of compliance support, PCI, ISO, SOC, HIPAA, and so on. In terms of how you can use FSx with your own organization's Active Directory, it's as simple as directly integrating your file system with your AD during creation of the file system. And in terms of authentication and authorization, your Active Directory users and groups are used for authenticating, so your users continue to use the same mechanism to access your file shares as they have been doing today. And then in terms of authorization, we support the use of the same NTFS ACLs to support file and folder level access authorization. We also support two different Active Directory integration options, AWS managed Microsoft AD as well as self-managed Microsoft AD, whether it's on premises or in cloud. So directly you can integrate it with your own Active Directory. In terms of the self-managed, it's as simple as saying, here's my domain name, here's the DNS server IP addresses for my domain, and here's a service account username and password with which FSx can join the file system to my Active Directory. That's it. So it's a typical domain join sort of experience. In terms of backups, we provide highly durable backups that are stored in Amazon S3, as I mentioned earlier. We also support full file system consistency using the Windows native volume shadow copy service, or VSS. With this, we allow you to capture a point-in-time view of your file system and to recover to that point in time. We also support incremental backups, meaning that only changes from your most recent backup would occupy additional backup storage, and you would pay for that additional backup storage. And of course, backups are fully managed, where we take care of everything behind the scenes for you. You're not responsible for where they're stored, how they're managed, how they're retained, how the retention policy is applied, so on and so forth. And then in addition to backups, we also support file-level restores by end users. So end users can undo changes to individual files or undo deletes, things like that. There's no need to even go to your admin and file a ticket. The end user does it by themselves, like this screenshot shows. You just use the Windows native GUI to right-click on a file, say properties, and then recover a specific previous version. In terms of administration, we support two ways of administering your file system resources. So for your AWS resources, we support the use of console and CLI, as we already talked about. You can look through all of this and manage all of these things. And then for file system features, we provide a separate PowerShell-based remote management CLI. With this, you can manage things like file shares, shadow copies, data deduplication, user quotas, and so on. And here's just an example of how easy it is to administer your file system features using PowerShell. In this case, I'm just getting a list of all the shares on the file system by running the get-fsx smb share command. The last topic I'll touch on before handing it over to Daryl is migration. FSx supports a simple and seamless migration path for your workloads. You can migrate your files using Windows native tools like Robocopy. You can preserve all of your existing file system ACLs and DFS namespace names. You can continue to use your existing AD user identities, so there's no need to modify any of those things. We also provide tooling on our documentation to migrate your existing SMB file shares transparently from your existing file setup to FSx. So really the key here is there's no need to modify anything to migrate your files over to FSx. So let's now look at FSx in action with Daryl's demos.
Great. Excellent. Thank you. Thank you, Prash. And welcome, everyone. As Ed mentioned, creating an FSx for Windows File Server is very easy. So what we're going to do is create one right now in the AWS Management Console. So within the FSx console, click on Create File System. we want to create an Amazon FSx for Windows File Server. There are two options. So when we launched FSx last year at reInvent, there are two file system types. We have Amazon FSx for Lustre, as well as Amazon FSx for Windows File Server. So we'll select Amazon FSx for Windows File Server. Here we can go ahead and just give it a name. This is like a tag that will associate with the file system. So we'll call it STG306. We'll actually create a multi-AZ file system today. We will give it a capacity of, say, 4 terabytes. And when I tab off, we'll see that the recommended throughput for this file system sized at 4 terabytes is 64 megabytes per second. So I've done some testing. I've done some benchmarking on my application. I know that I need a little bit more than that. So I'm going to select 256 megabytes per second for my file system for this workload. Next, I need to select where my file system will reside. So here, what I need to do is it looks like I was logged out. Give me one. Let me do a refresh. Of course. So let me hop over here, put in my password so no one can see. All right. There we go. Now we'll get back to it. So let's go ahead and start again. We'll create a file system. Again, we'll call this STG306. It'll be a multi-AZ file system, 4 terabytes, with a throughput capacity of 256 megabytes per second. I actually have a special VPC for my environment, so I'm going to select the VPC. I also have a sub-security group that I created for this test, and it's the file system security group. So this is the security group that's going to be associated with this Windows server that's going to be hosting the file system. So we want to make sure that that security group has inbound access to allow SMB traffic to the file server. Next, the two subnets. So the preferred subnet, I want to put this in my private subnet 0, and the standby will put it in private subnet 1. I have an Active Directory already created, so that's going to be a AWS managed Active Directory. I'll continue to use the default encryption key. And when I scroll down to the maintenance preferences, I could select when I want to have a daily automatic backup taken of my file system. So this is a 30-minute window each day when an automatic backup is going to be taken. This is a file system consistent incremental backup. I don't have a preference, so I'll leave it at no preference. I can also set the number of the retention period for my backups. This could be anywhere from 0 to 35 days. So I'll just keep it at the default of 7. Next is the weekly maintenance window. So here, again, we can select when each week the maintenance window will occur. This is a 30-minute window that if a OS patch is required for your environment, we would deploy that patch in this 30-minute window. I don't have a preference for this, so I'll keep it at no preference. Click on Next. I can review all the different settings for my file system and click on Create. So it's really that simple. Now that we have a file system creating, I have a couple other file systems here as well. Let's go ahead and take a backup of an existing file system. So here I have a file system. Once you go into the file system, you can take a look at some of the attributes. We can see that this one, too, is a 4 terabyte file system with 256 megabytes per second throughput capacity. If we click on the Backups tab, we can see all the backups that already exist. But let's go ahead and take another backup of this file system. So at the very top, we can click Actions, Create Backup, and just give it a name. And that's it. Click on Create. You can also create a backup using the CLI or API. So again, it's just an API command, create a backup, and these backups are file system consistent incremental backups that are stored in S3. So highly durable, highly available. We also have the ability to create a file system from a backup. So let's say that I already have a backup of this file system, but we want to create a new file system based on this backup. Very simple to do that as well. So I'll select an existing backup that's available, click on Restore Backup. Then here I could give it, you really walk through the exact same Create File System wizard screen as you're creating a file system, but when you're doing it for a backup. So again, I could go ahead and type in a name here, STG306 single AZ. And we'll just call it Restore. It's a single AZ file system. The storage capacity is the 4 terabytes. I could change the throughput capacity if I wanted to. So we could say this is going to be a 512 megabyte per second file system. Again, I would select which VPC, the subnets, all of that here as well as the Windows authentication. Once I'm done, go ahead and click on Create or Restore File System, and it will create a brand new file system based on the backup of this, the backup that I used. We're not going to finish that, but what we are going to do is we're going to now map a drive to an existing file system. So I have this single AZ file system that we'll use. Now I have a Windows EC2 instance right here that has already been joined to the same Active Directory or domain as my FSX for Windows File Server. So what I want to do is go ahead and go into File Explorer, map a network drive, and I'm going to map the single AZ file system as S. So what I need to do is go back to my console, select the DNS name of the file system that I want to map, put it in as a UNC path, and every file system has a default share called share. So very easy. You can also create new shares at that same level, just using the share file management plugin or console. Now that we have that one mapped, let's go ahead and map the multi-AZ file system as well. So I have an existing multi-AZ file system created. I'll go ahead and grab the DNS name for that one as well. We'll go back to my EC2 instance, map a network drive. This time we're going to map it as M. Makes it easy for me. And again, the default share is going to be share. So now we have 2 file systems, or 2 file shares mapped to this instance. And now what we're going to do is run a couple of tests and compare the read and write performance between a single AZ and a multi-AZ file system. So here we're using disk speed. And this first test we're going to go ahead and run against the S drive. So this is against our single AZ file system. So I'm going to kick that off. I'm going to go ahead and start Task Manager and take a look at the performance of our network. So after a few seconds, it'll actually create that file. And then we're going to see some activity. So we'll see it up here. We're getting around 4.9, close to 5 gigabits per second throughput. So this file system, as you saw, has a total throughput capacity of 256 megabytes per second. So 5 gigabits per second is roughly, it's around 600 megabytes per second. So I'm achieving that much write throughput to this file system. We can go ahead and scroll up, and it looks like we have, around 571 megabytes per second throughput on this write test. So let's go ahead and grab the test for the multi-AZ as well. We'll run this. We'll go back to Task Manager and take a look at how this is running. So after a few seconds, we'll see that the file has been initiated and created, and then it'll start its write test. So very similar results. We see that we also are around 4.8, 4.9 gigabits per second throughput. Again, this file system also has a 256 megabytes per second total throughput for the file system. So here we can scroll up. we can see that this achieved 582 megabytes per second throughput, so a little higher than our single AZ file system that we tested. So very comparable speed for both single AZ file systems and multi-AZ file systems. Now let's go ahead and do a test, a read test. And this is for the single AZ. It's writing to the S drive. There we go. Now we started it. And again, what do you expect on the performance? Around 5 gigabits per second. So again, we are achieving around 600 megabytes per second throughput on this test. So it'll finish here within the next 20 seconds. We'll take a look at what the results are, and we'll move on to the multi-AZ file system. We'll scroll up and take a look. And here we were achieving 571 megabytes per second on this test. And let's grab the multi-AZ file system script. And what kind of results do we expect? Around the same. We're going to see that we're going to be getting around 5 gigabits per second, or 625 megabytes per second on this file system. I have another instance. And so what I'm going to do is run a little longer test against a different file system in a different region. This, too, also has a single AZ and a multi-AZ file system attached to it. I'm going to run it here and run it a little longer so we can actually see the metrics in the FSX console. So we launched a few weeks ago a new console that has a monitoring tab. And within that monitoring tab, we have CloudWatch widgets, where we can actually see now the performance of that file system we selected within the console. So just want to make sure this is started. Looks like we are getting around 5 gigabits per second throughput. So we'll go ahead and move on with the rest of the test. We'll come back to this. Next thing I want to do is actually enable deduplication. So in order to do this, we need to get the remote PowerShell endpoint for my file system. So we'll go ahead and select the file system I want to use. We'll scroll down. We'll get the Windows Remote PowerShell endpoint. So what I want to do is copy this into my script right here. And I'm going to establish a remote PowerShell session to my FSX file server. Now that that's established, what we're going to do is just take a look at some of the commands that are available in our CLI that we've provided. So if we scroll up, we can take a look at all the different commands that are available to you to help manage this FSX file server. We want to focus, though, on deduplication. So let's go ahead and get all the different dedupe commands. And the next thing we want to do is enable deduplication. Once it's enabled, we want to go ahead and set the schedule. So what I want to do is take a look at the time right now. So it is 7:43 p.m. UTC. So I'm going to change this to around 7:46 p.m. And this is when my deduplication, my optimization schedule, is going to run. Now that that is scheduled, I also need to change the minimum file age days. The default is 3. I want to change that to 0, so all the files that I loaded this morning in preparation for this demo will be deduped. Excellent. So now what we can do is take a look at the dedupe status. Nothing is run yet, so we're really not going to get anything. But we're going to come back to this within 3 minutes and take a look at actually how the dedupe optimization job is running. While we wait, we're going to get a shadow copy set up and actually take a shadow copy. So let's go ahead and take a look at some of the shadow copy commands that are available. So what we want to do is we want to go ahead and set the shadow copy default storage size. So does anyone attend the workshop we had a couple of days ago? Does anyone remember what the default maximum storage size is for shadow copies? 10%. So we have 10% of storage of the file system. So your shadow copies are actually stored within the total capacity of your file system. They're not stored outside of that. So you need to allocate how much storage within your file system that's going to be used for shadow copies. So we set that at the default at 10%. So we're going to use that. We're also going to set up a schedule. We're going to use the default schedule. So it's going to run at 7 and 12 throughout the weekdays. We don't have any shadow copies right now, so if we actually run this, we're going to see that we have 0 shadow copies. But what we want to do is we'll just go ahead and run a shadow copy right now. So we're taking a copy of the file system, basically a shadow copy of that file system. And earlier today, when Ed and Prash were working on the title slide, they created one and uploaded it to this file share. But I have my own version of it. So what I want to do is, let me open up a new PowerShell window. And I'm going to go ahead and load my version of the title slide. So I don't know if Prash and Ed will like this one, but we can go ahead and take a look at it. Let's go to File Explorer. We'll go to our drive. So we need to find the S drive. And here it is. So what we can do is take a look at this. And I like this version of it. But again, I don't know if Ed and Prash would. So now that I think about it, we are going to share this deck with you. So maybe I should actually revert back to my previous version of it. So very easy for end users to do. I can go ahead and click on this file, click on Restore Previous Versions. I'll see there's that previous version because I took that shadow copy and I made a change afterwards. That previous version is still there. So what I want to do is go ahead and restore the previous version. And it's really that simple. So now what we can do is go ahead and open that up. And this is probably the version that Prash and Ed would want me to share with everyone. So we're all good. And that's how easy it is to actually get shadow copies up and running. You can manually take a shadow copy at any time, or you can rely on the schedule. And you can set a custom schedule as well. One last thing that we want to do is let's go ahead and take a look at that performance of that file system. So this was running in a different region. So if we go back to the FSX console and we take a look at the file system, we can look at the monitoring tab. In that monitoring tab, we can see that, yeah, we're actually achieving 599 megabytes per second throughput. We can open this up within CloudWatch, take a really good look at it, make it a little larger. So we see consistently we're getting around 599 megabytes per second throughput writing to this file system. One last thing we want to do before we end is go back to our dedupe. So let me go ahead and grab our dedupe status, because by now that job has run. We'll go back to our remote PowerShell session that we have with our FSX server. And now that we can see we have 2,224 files that are being deduped right now, and the file saving rate is around 80%. So I'm receiving 80% storage reduction in storage capacity because I enabled data deduplication for this file share. Well, that is it for our demo. I think we are out of time. We do want you to, this is our contact information if you have any questions. And please fill out the evals for the session. If you do have questions, please come up. Or if we need to, we can answer the questions outside as well. Thank you very much.